Hello everyone, this is the second lecture on the topic interpolation. In the first lecture, we learned about definition of interpolation, interpolating polynomial and Weierstrass polynomial approximation theorem. The lecture 1 is already uploaded in this channel. Let us start the second lecture. Now, interpolating polynomial is always unique. We can prove this. Let fx be a function and let phi n x is equal to a0 plus a1x plus a2x square plus up to an x to the power n be interpolating polynomial where degree of phi n x is less than or equal to n, such that phi n xi is equal to f of xi for I is equal to 0, 1, 2 up to n. That is a0 plus a1 into xi plus a2 into xi square plus up to an into xi to the power n is equal to f of xi for I is equal to 0, 1, 2 up to n. That is, for I is equal to 0, a0 plus a1 into x0 plus a2 into x0 square plus up to an into x0 to the power n is equal to f of x0. For I is equal to 1, a0 plus a1 into x1 plus a2 into x1 square plus up to n into x1 to the power n is equal to f of x1. And similarly, for I is equal to n, a0 plus a1 into xn plus a2 into xn square plus up to an into xn to the power n is equal to f of xn. This system is system 1. Here a0, a1 up to an are unknowns. Now, the system 1 consists of n plus 1 equations with n plus 1 unknown. So, coefficient determinant of 1 is determinant 1 x0 x0 square x0 to the power n. Second row is 1 x1 x1 square up to x1 to the power n, and similarly the n plus 1th row is 1 xn xn square xn to the power n. This is n plus 1 cross n plus 1 matrix, determinant of n plus 1 cross n plus 1 matrix. Now we take 3 cross 3 matrix, determinant of 3 cross 3 matrix of the above form, and find the value of the determinant, that is modulus 1 x0 x0 square, 1 x1 square, and the third row is 1 x2 square. Now for simplicity we apply row operation, that is R2 minus R1, and for R3 minus R1. Then we get first row is 1 x0 square, the second row is 0 1 minus x0 x1 square minus x0 square, and the third row is 0 x2 minus x0 and x2 square minus x0 square. This equal to 1 x0 square, and the second row is 0 x1 minus x0 x1 minus x0 x1 plus x0, and the third row is 0 x2 minus x0 x2 minus x0 into x2 plus x0. Now taking x1 minus x0 from the second row and x2 minus x0 from the third row, we get x1 minus x0 into x2 minus x0 into determinant 1 x0 square, 0 1 x1 plus x0 and 0 1 x2 plus x0. This equal to x1 minus x0, x2 minus x0 and x2 minus x1. That is, it can be written as product I greater than j xi minus xj, for I j is equal to 0 1 2. Now we generalize this for the determinant of n plus 1 cross n plus 1 matrix. Therefore this equal to product I greater than j xi minus xj, for I j is equal to 0 1 2 up to n. This is obviously not equal to 0 as xi not equal to xj. Since the coefficient determinant of 1 not equal to 0, therefore a0, a1, an are unique. So phi nx, that is a0 plus a1x plus a2x square plus up to an x to the power n is also unique. That is, the interpolating polynomial is always unique, but the representation of interpolating polynomial may be different. That is all for today. If you like our classes, please do like, share and subscribe our channel for more classes. Thank you so much.